हेलो डियर स्टूडेंट्स, अस्सलाम वालेकुम। आई होप कि आप लोग सभी अच्छे से होंगे घर में। सो बेटा, आज जो हम पढ़ने जा रहे हैं दैट्स बॉयल्स लॉ। हाँ, आपने अच्छे से देखा होगा, इट्स बॉयल्स लॉ। सो हम पढ़ रहे थे स्टेट्स ऑफ मैटर। स्टेट्स ऑफ मैटर में हमने कुछ चीज़ें तो डिस्कस किए, हमने इंटरेक्शन डिस्कस किए, और आज जो हम डिस्कस करने जा रहे हैं दैट्स बॉयल्स लॉ। सो डियर स्टूडेंट्स, व्हाट इज दिस बॉयल्स लॉ? आप यहां जरा तवज्जो फरमाए, हम इस बॉयल्स लॉ को डिस्कस करने जा रहे हैं। सो व्हाट इज दिस बॉयल्स लॉ? बॉयल्स लॉ, प्रेशर ऑफ ए गैस इज इनवर्सली प्रोपोर्शनल टू इट्स वॉल्यूम। जो प्रेशर गैस का होगा, द प्रेशर ऑफ गैस इज इनवर्सली प्रोपोर्शनल टू इट्स वॉल्यूम। So this is Boyle's law. But dear students, you must remember it. Don't forget it. You must remember it. The pressure of gas is inversely proportional to the volume of gas at constant temperature and number of moles. आपको टेम्परेचर और नंबर ऑफ मोल्स फिक्स करने हैं, तभी जाके ये Boyle's law वैलिड है, तभी जाके प्रेशर ऑफ गैस इज इनवर्सली प्रोपोर्शनल टू इट्स वॉल्यूम, जब यहां पे नंबर ऑफ मोल्स और टेम्परेचर कांस्टेंट होगा, फिक्स्ड होगा। सो सबसे पहले बेटा, लेट अस डिस्कस व्हाट इज दिस प्रेशर। ये प्रेशर आप लोगों को पहले डिस्कस करना होगा, ये प्रेशर एक्चुअली है क्या। उसके बाद हम इस बॉयल्स लॉ का मैथमेटिकल पोर्शन देख लेंगे, मैथमेटिकली ये बॉयल्स लॉ बोलता क्या है। लेकिन पहले जरा यहां प्रेशर की तरफ आप तवज्जो फरमाइए, व्हाट इज दिस प्रेशर। बट रिमेंबर द लॉ इज लाइक दिस: pressure of gas is inversely proportional to the volume of gas at constant temperature and number of moles. You have to keep this number of moles and temperature fixed, otherwise the law is not valid. Okay dear students, now see dear students, सबसे पहले डिस्कस कर लेंगे व्हाट इज दिस प्रेशर। सो बेटा, लेट्स सपोज मेरे पास एक कंटेनर है बेटा, ये मेरे पास एक कंटेनर है, लेट्स सपोज एक कंटेनर है, और इस कंटेनर में लेट्स कीप some amount of gas, let's keep some moles of gas. Let's suppose we have kept some moles of gas here. Okay dear students, so you know one of the important property of gas is that these gas molecules are always in random motion. One of the important property of gas molecules is that these gas molecules are always in random motion and they collide with each other as well as with the walls of the container. So let's suppose yahan pe, let's suppose this is a unit area of this container. This is a unit area. Let's suppose this is a unit area of this container. सो बेटा आप समझ लीजिए, लेट सपोज ये एरिया कुछ भी हो सकता है, यहां से यहां तक। लेट सपोज ये एरिया इट्स इक्वल टू 100। सो अगर मैं लेट सपोज लेट्स डिवाइड दिस कंटेनर इनटू 100 पार्ट्स। सो अगर आप इसको 100 पार्ट्स में डिवाइड करोगे, सो यहां पे जो एरिया होगा इट विल बी इक्वल टू यूनिट एरिया. So these gas molecules will strike this wall, will strike this unit area. So what is the pressure? Pressure is the force with which this gas molecule will strike this unit area of container. The force with which this gas molecule will strike with the unit area of this container, that's called pressure. And remember, for the pressure, you have equation like this: pressure is equal to force divided by area. Force divided by area. So beta yahan pe dekhiye, what is this pressure? Pressure is a force with which this gas molecule will strike this unit area of this container, that's called simply pressure. So pressure of gas is a force with which this gas molecule will strike with the wall of container. But remember, you have to keep the area unit area. Okay dear students, so pressure of gas is inversely proportional to the volume of gas at constant temperature and number of moles. So let's discuss the mathematical portion of this Boyle's law, and after the mathematical portion we will discuss the graphical representation of Boyle's law. But remember one thing, that the pressure of gas is a force with which this gas molecule will strike with the wall of container, with which it will strike with the wall of the container. But remember dear students, that you have to take unit area of this container. Okay dear students, let's discuss the mathematical portion of this Boyle's law. So dear students, what is Boyle's law? Dear students, Boyle's law So dear students, Boyle's law The pressure of gas is inversely proportional to the volume. So it's like this. Pressure of gas is inversely proportional to the volume. What does it mean? It means if you increase the pressure, the volume of gas will decrease. जब आप कंटेनर के ऊपर प्रेशर इंक्रीज करोगे, द वॉल्यूम ऑफ गैस विल डिक्रीज, द वॉल्यूम ऑफ गैस विल डिक्रीज, और वाइस वर्सा. उसका मतलब क्या है? अगर आप प्रेशर को डिक्रीज करोगे, वॉल्यूम विल इंक्रीज, वॉल्यूम विल इंक्रीज. सो बेटा आप इसी इक्वेशन को इस फॉर्म में भी लिख सकते हो बेटा, P इज इक्वल टू K divided by V. What is this K? It's a constant, and this K is called Boyle's constant. It's called Boyle's constant. It's called Boyle's constant. So dear students, pressure of gas is inversely proportional to the volume. So we can write this equation like this. P is equal to K divided by V. And what is this K? It's a constant that's called Boyle's constant. So dear students, let's multiply this V with P. It will become PV is equal to K. Remember this equation. Remember this equation. This is important equation. So what does this equation says us? This equation says us, dear students, the product of pressure and volume is always constant. The product of pressure and volume is always equal to constant, and that constant is equal to K. So बेटा यहाँ पे देखिए, the product of pressure and volume is always constant. Let's discuss it. Let's discuss it. How it's equal to constant? It will be always equal to constant. So dear students, let's have a container. So बेटा let's suppose इसमें गैस भरी हुई है. Let's fill this container with some amount of gas. So let's suppose the pressure of gas P1, that's equal, let's suppose that's equal to 10, and the volume of this V1, volume of this container, let's suppose that's equal to 20. So let's suppose that यहाँ पे P1 V1 that will be equal to K. So P1 that's equal to 10 and V1 that's equal to 20, that's equal to K. So beta it's equal to 200. So here the K, that constant is equal to 200. So let's change the condition. So let's suppose we will decrease the pressure of this container. हम इस container का pressure decrease करेंगे. Let's decrease the pressure. आप प्रेशर को डिक्रीज कीजिए, then volume will automatically increase, because Boyle's law suggests us that if you increase the pressure, volume will decrease. If you decrease the pressure, volume will increase. Clear beta? So let's decrease this pressure. Let's decrease this pressure. Yeah, let's increase this pressure. So let's increase this pressure. आप pressure को increase कीजिए. If you increase the pressure, volume will decrease. So let's suppose हमने pressure को increase किया. हमने pressure को कितना किया बेटा? Let's suppose हमने pressure को P2. Let's keep this P2. Pressure is equal to 20. So we have increased the pressure. If we increase the pressure, the volume will automatically decrease down. So इसका जो volume बन जाएगा V2, that will be equal to 10. So again बेटा जब यहाँ पे आप इक्वेशन अप्लाई करोगे P2 V2 that will be always equal to K constant. So here you have pressure that's 20 and you have the volume that's equal to 10. So that's equal to K. Again that's equal to 200. That's equal to K. So बेटा यहाँ समझ लीजिए, it means that the product of pressure and volume that's always equal to constant. So product of pressure and volume is always equal to constant. So let's have a container, and this container is filled with some amount of gas, and here the pressure is equal to 10 and volume is equal to 20. So P1 V1 that's equal to K. 10 multiplied 20 that's equal to 200. So then what we are going to do, let's increase the pressure. If we increase the pressure, the volume will automatically fall down. So we have increased the pressure up to 20 and volume will become 10. So P2 V2 that's equal to K. Again it's equal to 200. So that means the product of pressure and volume will be always equal to constant. If you increase the pressure, the volume will itself adjust in such a manner that the product of pressure and volume will always remain constant. So whenever you will change the pressure, the volume will itself adjust in such a way that the product of pressure and volume will be always equal to constant. So dear students, I hope you got it. Okay, dear students. So what is Boyle's law? P is inversely proportional to V. P is equal to K divided by V, and this K is a constant, and it's called Boyle's constant. So let's multiply this V with P, so it will become equal to PV is equal to K. That means this equation is very important, and it suggests us that the product of pressure and volume will always equal to be the constant. So how? Let's take the example. So we have a container, and the container is filled with some amount of gas, and we have kept the pressure that's equal to 10, and we have kept the volume that's equal to 20. So the product of pressure and volume that comes out to be equal to 200. So if you change the pressure of this container, if you change the pressure, so pressure, you have increased pressure becomes 20. When you increase the pressure, the volume will fall down and volume becomes equal to 10. So again, the product of pressure and volume comes out to be 200. That means that the product of pressure and volume will be always equal to constant. Okay, dear students, I hope you got it. So one more important equation you will get here. So let's suppose apply log on both sides to this equation. If we apply the log to this equation on both sides, it will become a very beautiful equation, very beautiful equation. So let's apply the log on both sides, and let's see what it becomes. Apply log on both sides. So it will become log PV is equal to log K. So apply log on both sides to the above equation. So it will become log P V is equal to log K. So dear students, log P V is equal to log K. Here we have one important mathematical equation. That's log M multiplied by N. That's equal to log M plus log N. So here M N. So log Mn, that will be equal to log M plus log N. But in place of M, you have P. In place of N, you have V. So log Vp, that will be equal to log P plus log V. So dear students, so let's see. It will become, dear students, it will become, wait a minute. It will become log P plus log V, that's equal to log K. I hope, dear students, you got it. Now transfer this log V to the other side, so the equation will become like this. Log P is equal to minus log V plus log K. So dear students, now see, we will have one important equation, very beautiful equation, very beautiful equation. So let's multiply this equation with 1. It will become log P is equal to minus 1 multiplied by log V plus log K. So this equation is very important equation, very beautiful equation, very beautiful equation. Now what is it? It is equal to y is equal to mx plus c. It's a straight line equation but with negative slope. That slope is equal to minus 1. That slope is equal to minus 1. We will discuss all the graphical representation of this Boyle's law, but wait few minutes. Before doing that graphical representation of Boyle's law, let's discuss the mathematical portion of this Boyle's law. So I hope, dear students, you got the mathematical portion of this Boyle's law. So this equation, we have applied log on both sides. So the equation will become log PV is equal to log K. But here we will have a mathematical formula that's equal to log M multiplied by N. That's equal to log M plus log N. So log, in place of M, we have P. In place of N, you have V. So it will become log P plus log V. That's equal to log K. So it's, then we have transposed this V to the other side, so the equation will become log P is equal to minus 1 log v multiplied by log k. So the equation is y is equal to mx plus c. Y is equal to mx plus c. It's a straight line equation with the negative slope. So dear students, remember जो भी equation मैं यहाँ पे ब्रैकेट में रख रहा हूँ, जो भी मैं equation एक डब्बे में रख रहा हूँ, उस equation का हम ग्राफ जरूर देखने वाले हैं. उन equation का ग्राफ हम जरूर देख लेंगे. We will discuss the graphical representation of this Boyle's law. So dear students, now this equation can be rewrite in the another form. We can write this equation in another form. हम इस equation को एक और form में लिख सकते हैं. What you have to do, you must know the mathematics. You must know the mathematics, because you cannot do good in NEET, you cannot do good in physics and chemistry until you don't know the mathematics. Mathematics is very much important. So dear students, let's rewrite this equation in another form. So let's suppose beta it's equal log p is equal to log 1 by v plus log k. So this equation log p is equal to minus 1 log v plus log k. We can write it in another form, because it will become equal to log p is equal to log 1 by v plus log k. If you do again the mathematics to this equation, it will again turn in this form. So let's again multiply to this equation by 1. So it will become equal to log p is equal to 1 multiplied by log 1 by v plus log k. So again it becomes a beautiful equation. It's equal to y is equal to mx plus c. So what's the difference between this and this equation? Here the slope was negative, but here the slope is positive. So in both the equation, the only difference is the slope. In this equation, the slope is equal to minus 1, and in this equation, the slope is equal to positive. That's equal to 1. So let's discuss the graphical representation of this Boyle's law. So beta, remember what is this Boyle's law? Boyle's law, it is the pressure of gas is inversely proportional to the volume, but keep the temperature and number of moles fixed. अगर आप लोगों ने वो fix नहीं किया, then Boyle's law is not valid. Okay, so that is mathematically P is inversely proportional to V. That's equal to P is equal to K divided by V. Then multiply the V with P, it becomes PV is equal to K. That equation is very important, because that equation suggests that the product of pressure and volume will always remain constant. So then we applied log on both sides, then the equation becomes log P is equal to minus 1 log V plus log K. It's y is equal to mx plus c. It's a straight line equation, but here the slope, that's negative. So this equation can be written in another form. That's equal to log P is equal to log 1 by V plus log K. Multiplying this equation with 1, multiplying log 1 by V with 1, so it will become y is equal to mx plus c. Again, it's a straight line equation, but here the slope is positive. So dear students, let's discuss the mathematical portion of this Boyle's law. But before discussing Boyle's law, before discussing the graphical representation of Boyle's law, you must remember the Boyle's law. Must remember the Boyle's law. Okay, dear students, wait a minute. So dear students, let's have a graphical representation of this Boyle's law. So what is Boyle's law? Let's first graph for Boyle's law. P versus V. P versus V. So dear students, P versus V. P versus V. So dear students, when you increase the pressure, the volume will automatically decrease. So let's suppose it's equal to 4, 6, 8, 10. 2, 4, 6, 8, 10. So dear students, when you keep the pressure highest, the volume will be lowest. But if you decrease the pressure, the volume will increase. So the graph will be like this, rectangular hyperbola. A rectangular hyperbola. So number second. So this number second, PV versus V. So dear students, the product of pressure and volume will be always equal to constant. If you increase the pressure of or volume, let's take volume or pressure. If you increase the pressure, the product of pressure and volume will remain always constant. Because when you increase the pressure, the volume will adjust itself in such a way that the product of pressure and volume will always remain constant. Or if you increase the volume, the pressure will adjust itself in such a way that the product of pressure and volume will always remain equal to constant. So beta PV versus V or P, it will be always constant parallel to x-axis. Okay, dear students. Let's have a third graph. Let's have a third graph. Let's have a third graph. So third graph, that's equal to log P versus log V. So it's like this. Log P, log V. So what was that equation? When you applied log on both sides, that equation was like this. Log P is equal to -1 multiplied by log V plus log K. This was the equation. When you applied log on both sides, the equation becomes log P is equal to -1 log V plus log K. That's equal to Y is equal to mx plus C. Y is equal to mx plus C. So this Y, this X, this C. So here the M, this M is the slope. That's equal to tan theta. That's equal to here M. And this M is equal to here -1. This M is here equal to -1. So this M is equal to slope, that slope is equal to tan theta, and tan theta here is equal to M, and that M is equal to 1. So it's a negative slope. So the equation is a straight line equation. Whenever you have straight line equation, there is a possibility of two types of graphs. Number first, if slope is negative, then graph comes downwards. That a straight line comes downwards. If you have slope positive, then the straight line will go upwards. But here the slope is negative, it means that the straight line will come downwards. So the graph will be like this. And here will be some angle theta. Okay, dear students, I hope you got it. So the log P versus log V is a straight line equation with negative slope. Whenever you have straight line equation, there is a possibility of two types of graphs. Either it can go upward or it can go downward. If you have slope negative, then that straight line will come downward. If you have positive slope, then that straight line will go upward. Okay, dear students, I hope you got it. So then what we are going to discuss, now we will discuss one more graph, but that graph will be log P versus 1 by log V. So let's see what will happen. So number fourth graph. So it's log P versus log 1 by V. It will be like log phi. Dear students, please be focused. Log 1 by V. So let's first discuss what was the equation. Log P versus log 1 by V. That equation was like this. Log P is equal to 1 multiplicable log 1 by V plus log K. So dear students, again it's a straight line equation. It's y is equal to mx plus c. Y is equal to mx plus c. But here, what's the difference? That the slope that's equal to positive, that's equal to 1. So again here, the slope that's equal to tan theta. That's equal to tan theta. That slope is equal to tan theta. That's equal to here m. But this m here is equal to plus 1. So here the slope is positive, and whenever you have a slope positive, the straight line equation, the graph is like this. It will go upwards. It will go upwards, and it will start from here because you have some intercept. You have some intercept, and that intercept is equal to log k. This is equal to intercept. That's equal to log k. I hope you got it. I hope you got it. I hope you got it. Dear students, please be focused. Be focused. So whenever you have graph log p versus log 1 by v, it will be a straight line, but with some intercept. That intercept is equal to log k. Okay, dear students, and you can calculate here. You can calculate the slope from here. You can calculate the slope from here. But if you know the mathematics, if you are good in mathematics, then actually you can extrapolate this line. You can extrapolate this line, and it will form here an angle. But this angle and this angle, that will be that angle and that angle will be similar because of similar triangles. In similar triangles, the angles are always equal. The angles are always equal. Okay, dear students, I hope you got it. I hope you got it. I hope you got it. So, but remember one thing. Remember one thing. What's that? That the Boyles law is valid only when you keep the temperature constant. When you keep the temperature constant, and you know, whenever the temperature is constant, that means that all these graphs are called isothermal graphs. Isothermal graphs. So dear students, what are isothermal graphs? Isothermal का मतलब होता है whenever you keep the temperature constant, it's called isothermal process. So all these graphs are drawn at constant temperature. So if the temperature is constant, students, then these graphs are called isothermal graphs. So dear students, for 2020-21, one important question was asked from this Boyles law in NEET 2021, that was about the graph. So उस ग्राफ में आपको क्या देखना था? आपको देखना था which of the following is the correct graph for Boyles law, और उसमें दिए गए थे relationship between T1, T2 and T3. So let's discuss. If you change the temperature, and you have to find out the relationships between T1, T2 and T3, you can easily find out. So let's have one more graph. So again, it's graph number 6. So let's draw this graph. P versus V. And you know, P versus V, the graph is rectangular hyperbola. Yes, you heard it correctly. The graph between P versus V is rectangular hyperbola, and it's like this. So, but what I am doing here, I am not keeping the temperature constant. I am changing the temperature. So, and you have to find out the relationship between all these temperatures. So, let's suppose one more curve. Let's have one more curve. So, but let's suppose it's equal T1, it's equal T2, it's equal to T3. So, here a graph between P versus V, but these graphs are drawn at different temperatures. So you have a temperature T1, you have temperature T2, you have temperature T3. And what you are going to do to find out the relationship between T1, T2 and T3. So how can you find out the relationship between T1, T2 and T3? Now beta, please, for a minute, have a fully concentration towards me, have a fully. So it's like this. PV is equal to nRT. It's ideal, this equation PV is equal to nRT. So dear students, this n, it's a constant. This R, it's also a constant. So we can write PV is equal to T. Or we can write P is equal to T divided by V. So dear students, if pressure is more, temperature is also more. If pressure is more, temperature is also more. So let's find here. Let's have here. So this is, now see, 41. Please beta, be focused. 41, you have pressure this amount. 42, you have pressure this amount. 43, you have pressure this amount. So now see, more the pressure, more is the temperature. Now see, 43, you have more pressure. If pressure is more, then temperature is also more. If pressure is less, then temperature is also less. 41, you have a less pressure. If pressure is less, then temperature is also less. So you have T3 is greater than T2 is greater than T1. Or you can write like this, T1 is less than T2 is less than T3. And remember beta, NEET 2021, one question was asked from this Boyles Law, and that question was based upon the graph, and I will show you that graph. So you can simply calculate a relationship between T1, T2 and T3. That's like this: PV is equal to nRT, PV is equal to T, P is equal to T divided by V. So here P is directly proportional to temperature. More the pressure, more is the temperature. Now how you can find out it? From here. For T1, you have pressure this amount. For T2, you have pressure this amount. For T3, you have pressure this amount. So more the pressure, more the temperature. So that means T3 is greater than T2 than T1, or T1 is less than T2 and T3. Okay, dear students, I hope you are getting it. Okay, dear students, please wait a minute. Okay, dear students, let's have one more graph. So again, it's like this. It's graph number 8. So it's P versus V. So let's suppose it's like this: a rectangular hyperbola, number first. But again, I'm drawing these graphs at different temperatures. So it's like this. 600. It's like 400. It's like 200. Okay, dear students. And the same question was asked in NEET 2021. So let's have here. So here pressure. Now you can see, for 600 Kelvin, you have pressure this amount. For 400 Kelvin, you have pressure this amount. For 200 Kelvin, you have pressure this amount. So here the pressure is less. If the pressure is less, then temperature is also less. But here pressure is more. If the pressure is more, then temperature is also more. So this graph is correct. This graph is correct. This graph is correct because for 600 Kelvin you have more pressure. So more the pressure, more the temperature. So here pressure is more. If pressure is more, then temperature is also more. But for this 200 Kelvin, you have less pressure. If pressure is less, then temperature is also less. But dear students, let's have one more. Let's have one more. This graph is not correct. This graph is not correct. This graph is not correct. Again, it's rectangular hyperbola. Again, it's rectangular hyperbola. But what I am doing, it's 300 Kelvin, it's 600 Kelvin, it's 100 Kelvin. It's 100 Kelvin. So this is 100 Kelvin, this is 600 Kelvin, this is 300 Kelvin. It's not correct. Now see, for 300 Kelvin, you have pressure this amount. For 600 Kelvin, you have pressure this amount. For 100 Kelvin, you have pressure this amount. So here pressure is more. If pressure is more, then temperature must be more. But here the temperature is less. So this graph is not correct. This graph is not correct. Because you know pressure is directly proportional to T. If pressure is more, then here temperature must be more. But here the temperature is less. Here pressure is less, but temperature is more. So this graph is not correctly represented. So if here pressure is more, then here temperature must be more, but here temperature is less. So this graph is not correct. So this graph is not correct. This graph is not correct. I hope, dear students, you are getting it. You are getting it, dear students. Okay, let's have one more. Let's have one more. Let's have one more. Let's have one more. So graph number 10. So it's equal. It's PV versus P. So remember that equation. That equation was very much important. That the product of pressure and volume is always equal to constant. If you are going to change pressure, if you are going to change the pressure, the product of pressure and volume will not change. Because if you change the pressure, if you increase the pressure, the volume will adjust itself in such a way that the product of pressure and volume will always remain constant. So PV versus P. If you are going to change pressure, the product of pressure and volume will not change. That will be always equal to K. So that graph will be constant parallel to x-axis. But what I am doing here, I am not going to keep temperature constant. I am not going to draw this graph at isothermal condition. I am changing here temperature. So if I am changing here temperature, so let's see what will happen. And you have to find the relationship between T1, T2 and T3. So let's suppose it's T1, it's T2, it's T3. I hope you are getting it. Dear students. So again, you can find the relation from PV is equal to nRT. What was that equation? PV is equal to nRT. So beta P, N and R, that's constant. So we can write P is equal to T divided by V. Again, you can find here relation. Or you can simply write it like this. Or simply you can write it like this. You can write it like this. You can write it this. PV is equal to T. Because more the temperature, more is the PV here. So you can find it from here. So here PV is less. Here PV is more. Here PV is more. So that means T3 is greater than T2 is greater than T1. So because PV is directly proportional to T, for this T1 you have PV less, for T2 you have PV this amount, for T3 you have PV this amount. So more the value of PV, more is the temperature. So that means T3 is greater than T2 is greater than T1. Okay, dear students, I hope you are getting it. So let's have one more graph. Let's have one more graph. So the graph is like this. Log P versus log V. Log 1 by V, let's suppose. Log 1 by V. So it is a straight line equation with positive slope. So it's T1 is T2, it's T3. So again, for T3 you have more pressure, for T1 you have less pressure. So again, T3 is greater than T2 is greater than T1. So I hope you are getting it. I hope you are getting it. So in next lecture, we will continue this Boyle's law, because we have to draw few more graphs for this Boyle's law, and we have to discuss some more important equations for this Boyle's law, which we are going to use in problems, in numericals. That mathematical portion we will discuss in the next lecture, and we will draw few more graphs for this Boyle's law. Okay, dear students, Allah Hafiz.